Okay, so we discussed yesterday Cauchy sequence, right? And saw that 1 is equal to 1, xn in of terms, algebraic mean, then n is Cauchy. That this is therefore n is convergent, and also we found limit, so limit of xn 5/3, right? So let n is equal to 1 plus uh, 1 by n is equal to 1.
Excuse me, sir.
Yes.
Sir,
So
your
we can't
voice is too low. We can't hear you.
Is it clear now? Yes.
yes, sir.
Am I audible?
Yes, sir.
Okay. So, okay, let xn is equal to, okay, x1. Let us say x1 is equal to 1 upon 1 factorial. So, x1 is equal to 1 upon 1 factorial. x2 is equal to 1 upon 1 factorial minus 1 upon 2 factorial. x3 is equal to x3 is equal to 1 upon 1 factorial minus 1 upon 2 factorial plus 1 upon 3 factorial. Right. In this way we define xn. So what could be the general term of sequence xn? What would be general term? 1 upon 1 factorial minus 1 upon 2 factorial plus 1 by 3 factorial and so on. What will be the last term? Means last number in xn. In x3 last number is 1 by 3 factorial, but it is positive, right? Therefore last number is 1 by n factorial, but what is the sign? What will be sign?
If n is even, it is negative, and if n is odd, it is positive.
Therefore it is minus 1 raised to n plus 1. If n is even, then it is n plus 1, it is minus, and so on. So this is a general term. This is my sequence xn. Now I want to check that whether it is a Cauchy sequence or not, right? So through that, and then I can decide whether it is convergent. So through that, xn is convergent. So how to prove that xn is convergent? So first, it is directly, it is not, in some sense, it is not easy, but uh, we can show that it is Cauchy. So let m greater than n. Suppose you choose any n and m greater than n. Then let us see what is ym minus yn. What is ym minus yn? So m is greater than n. Therefore, first write ym 1 minus 1 by 2 factorial plus 1 by 3 factorial. Right. Yeah. And what is the final? Minus 1 raised to m plus 1 divided by m factorial. In between there will be somewhere 1 upon minus 1 raised to n plus 1 upon n factorial and remaining terms. This is ym minus yn 1 minus 1 upon 2 factorial plus 1 by 3 factorial and so on, minus 1 raised to n plus 1 upon n factorial. So this is yn. ym minus yn. So is it clear? Because m is greater than n, so the ym is bigger, or more terms. Now some terms get cancelled. So which terms get cancelled? Up to 1 upon n factorial. All these terms get cancelled because 1 minus 1 by 2 factorial plus 1 by 2 factorial. So all terms get cancelled. So ultimately what remains? What remains?
Minus one.
Upon n plus 1 factorial minus 1 raised to n plus 2. Correct?
N plus
Minus 1
Yes,
raised
sir.
to n plus 3 divided by n plus 2
plus
factorial up to last.
m plus
Right.
1 upon n factorial.
Right. So now let us take absolute value and see what happens. Can you guess what is the value of k for given epsilon? Right. First we estimate something, simplify the difference so that we can understand. So therefore ym minus yn, this difference is minus 1 raised to n plus 2 upon n plus 1 factorial and so on. Ultimately terms are alternate plus minus because the power of minus 1 is uh, odd and even. So minus 1 raised to m plus 1 divided by m factorial. Now, but can I eliminate these minus signs or get rid of this? So by triangle inequality, right, plus minus 1 raised to n plus 3 upon n plus 2 factorial and so on, minus 1 raised to m plus 1 upon m factorial. So this is by triangle inequality. But whatever is the numerator plus minus, it is plus 1 or minus 1, right? And if you take absolute value, it is just 1 upon n plus 1 factorial plus 1 upon n plus 2 factorial. Whatever is numerator plus or minus doesn't matter, right? Now, so use this 1 upon k factorial is less than or equal to 2 raised to k minus 1, which we already know for k greater equal to, right? Do you know this?
Yes, sir.
And therefore this quantity is less than or equal to what? This quantity is less than or equal to 1 upon 2 raised to n plus 1 upon 2 raised to n plus 1. Am I right?
Sir.
Right. So, but among these powers of 2, n is the least power and m minus 1 is largest. So I can take 2 raised to n common, 1 plus 1 by 2 plus 1 by 2 raised to 2, or 1 upon 2 to the power what? M minus n minus 1. You check the calculations if any, right? What is this bracket? Bracket is what? Geometric sum, right?
Geometrics.
So 1 minus 1 by 2 raised to m minus n divided by 1 minus half, because it is 1 plus r square, r raised to something minus 1. So therefore it is 1 upon 2 raised to n, and here half, 1 minus half is half, and you can write it as this. So bracket 1 by 2 raised to m minus n. But this bracket is less than 1. So I can say that this amount is less than 1 upon 2 raised to n minus 1. Right. So therefore what we have proved, thus for any m and n, if m is greater than n, then what we found ym minus y, what is my notation here xn. Notation is xn, I wrote yn, so xm minus xn. So therefore, what we found, xm minus xn is less than or equal to 1 upon 2 raised to n minus 1 for every m greater than n, whatever m n we have, this is true. And therefore, can you guess, so given epsilon, what is k such that, what is k such that xm minus xn is less than epsilon for all mn greater equal k. So what is k? Can you find k?
2 raised to k minus 1 should be greater than 1 by epsilon.
So we choose k such that we should choose k such that 1 upon 2 raised to k minus 1 is less than epsilon. Right. So how to choose this k? That means what? 1 upon epsilon is less than 2 raised to k minus 1. That means k is greater than 1 plus log of 1 by epsilon divided by log 2. Right. Therefore, if n is greater equal k, right, and you choose any m greater than n, then xm minus xn is less than 1 upon 2 raised to n minus 1, which is less than epsilon. That you can just verify, right? And therefore, what is the conclusion of this? What is conclusion of this?
Sequence is Cauchy.
Sequence is Cauchy. Therefore, sequence xn is a Cauchy sequence. And hence, xn is convergent. Right, so xn is Cauchy and therefore it is convergent. And therefore the terms are complicated, but we can understand it is Cauchy. But and there are more techniques to understand that. We uh, to understand that this the limit you can find. So there are some advanced technique with which you can find limit, but every time it is not easy to find the limit. We are sure that convergent, but exact limit, finding exact limit is difficult task, right? For that you need more things, but right now we are just interested in convergence, right? So you can do some experiments like this. We found that ym minus yn is less than 1 upon 2 raised to n minus 1. So this is true for every m and n. So you can think about yn minus y. Suppose uh, suppose limit of yn is xn is x, limit of xn is x, then you check that ki xn minus x can be uh, is tending to 0. So what is the appropriate value for x? That can be approximated. You can approximate, and it is possible to find approximate value. Sometimes that approximation is the only possibility. You cannot get exact value, right? Because if limit is irrational number, then you cannot get the exact number. This is a limit. You may get like e, right? So 1 plus 1 by n raised to n. What is the limit e? So e is a name for the limit of this function, but what is the exact value of e? 2 point something, but you cannot have finitely many digits, and on real line you cannot exactly locate, okay, this is the number is on real line, no doubt somewhere its position is there, but when we write in decimal, it is very difficult task, right? And therefore we are giving name this irrational number as E. In that way you can approximate it, right? So anyway, now there is one more technique so that you can understand the convergence. So and which is actually similar to the Cauchy sequence, right? So a sequence xn of real numbers is said to be contractive. Contractive sequence, if contractive means what? If you go further, right? If you go further, that means this is my first term, this is second term. So x1, x2, now x3, then x4, then x5, then x6, x7, x8, x9. Now from this figure, what do you understand?
Terms are
The
getting
terms
close.
are
Right. So if you go further, terms becomes closer and closer. Right. That means a sequence is set. So terms are contracting. The distance is contracting. So if there is a constant c, c is between 0 and 1, then that means c is a fraction. So fraction less than 1. So such that what is actually happening here, the distance between x3 and x4 is less than distance between x2 and x3, right? And this thing we want to write down in mathematical way. So such that distance between the xn plus 2 and xn plus 1 is less than or equal to c times distance between xn plus 1 and xn, right? So this is for all n. That means if you look at xn, xn plus 1 and xn plus 2, so distance between xn plus 1 and xn plus 2 is less than distance between xn and xn plus 1, and we are multiplying by fraction c, means the distance, the amount is fraction times, means it is very small, certainly small, not actually equal, right? So such sequence is called as a contractive sequence. So actually, if xn is contractive, then it is Cauchy, right? And therefore this is another way to look at a Cauchy sequence. If sequence is contractive, then it is Cauchy, and hence contractive sequence is convergent, because Cauchy sequence is convergent. So if sequence xn is contractive, it is Cauchy, and once it is Cauchy, it is convergent. Is convergent, right? And it is not difficult task to show that contractive sequence is Cauchy, because uh, if you look at distance between two successive terms, then you can reduce it. So distance between xm and xn you can reduce, as we did in the previous example. How did we calculate distance between xm and xn? We just look at a distance between two successive terms, and using that you calculate distance between xm and xn in the example which we discussed. So that is the idea here also, but we'll discuss this proof later on, or if we get sufficient time. Otherwise, right now it is not that much important, but you can understand, or you can on own you can understand the proof, not very difficult, right? So let us see example of such contractive sequence. So let uh, x1 is equal to okay, let x1 is equal to a number between 0 and 1, whatever is it, doesn't matter, and xn plus 1 is 1 by 7 times xn cube plus 2, right, or n greater equal 1. So in this way I am defining my number. Suppose x1 is equal to half, whatever number you select doesn't matter, or for the simplicity let x1 is equal to half. Therefore what is x2? 1 by 7 times half cube plus 2, right? What is it? What is it? 17 by
56.
right, 17 by 56. So this is x2. Similarly you can calculate x3 and so on. So these are the terms. Now we want to prove that xn is contractive, right? Now we want to prove that this sequence is contractive. Contractive means what we need to prove? If you want to prove that this sequence is contractive, what we should prove? By definition, if we want to find a number c such that key distance between two terms is less than or equal to c times distance between previous two terms for every n. If this is going to happen, then we can easily say that this sequence is contractive. So let us try to do this. What happens? So start with, so consider now consider xn plus 2 minus xn plus 1, right? Let us try to calculate this difference and see what happens. So by definition of xn, what is xn plus 2? Now you tell me what is xn plus 2. By definition, what is xn plus 2? This is xn plus 1.
1 by 7 into xn plus 1 q plus 2.
Right. So 1 by 7 into xn plus 1 cube plus 2 minus, what is xn plus 1? So 1 by 7 xn cube plus 2, right? So 1 by 7 I can take it outside. What is inside the modulus? So plus 2 minus 2, plus 2 minus 2 is cancels, get cancelled. So xn plus 1 cube minus xn cube, right? Okay,
Yes.
so okay, now it is a minus b, a cube minus b cube. What is it? A minus b into a square plus ab plus b square. Is it correct?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So minus xn plus 1 square plus xn plus 1 into xn plus xn square. So I am using the expansion a cube minus b cube. So this is 1 by 7 into xn plus 1 minus xn into another absolute value xn plus 1 square. Okay, so what we obtained so far, xn plus 2 minus xn plus 1. This is what we have obtained. Okay, let us call it as 1. Now, well, so since x1 belongs to 0 to 1 or 0 less than x1 less than 1. And what is x2? 1 by 7 x1 cube plus 2, right? So is this less than 1 by 7 into 1 plus 2, that is 3 by 7? Is it true?
Yes, sir.
And 3 by 7 is less than 1, right? So 3 by 7 is also less than 1. Therefore x2 is in between 0 and 1. What about x3? What about x3? By same logic, what is x3? 1 by
It is
7
also
into,
less than 3 by 7.
right? And it is less than, by same logic, because x2 is less than 1. So by induction, we can prove that, right? You just follow the induction steps. It is not difficult, right? We can prove that 0 less than xn is less than 1 for all n. Fine. So now this is a important step. Now what was our first step? First expression. So by 1. So therefore xn plus 1 square plus xn plus 1 xn plus xn square, by triangle inequality, xn plus 1 square plus xn plus 1 into xn, right, plus xn square, or the absolute value square is same thing in this case. But this is less than or equal to, xn plus 1 is less than or equal to 1 and it is non-negative, so no need of absolute value basically. But this is less than or equal to 1. Xn plus 1 is less than or equal to 1. Xn is less than or equal to 1. So therefore 3. So second bracket is less than or equal to 3. Therefore by 1, by expression 1, xn plus 2 minus xn plus 1, which we had, is equal to 1 by 7 into xn plus 1 minus xn into second bracket xn plus 1 square plus xn plus 1 xn plus xn square, right? But this second absolute value is less than or equal to 3, so 1 by 7 into xn plus 1 minus xn into 3. So ultimately what we can say here, so 3 by 7 xn plus 1 minus xn, right? And therefore what we found, the xn plus 1 minus xn plus 2 minus xn plus 1 is less than or equal to 3 by 7 times xn plus 1 minus xn. Now can we say that ki xn is contractive from this?
Yes, sir.
Yes, because what is c here?
3 by 7.
3 by 7.
Right. Therefore xn plus 2 minus xn plus 1 is less than or equal to c times xn plus 1 minus xn, where c is equal to 3 by 7 less than 1, and this is true for all n. Therefore xn is contractive. Therefore every contractive sequence is Cauchy, so xn is Cauchy. And one more thing, you can directly prove that this sequence is Cauchy, right? And hence it is convergent, right? Previous steps. Okay. Okay, is it complete? Is it clear?
Yes, sir.
Yes.
Uh, Fine. So,
Okay, sir.
ah, so uh, this sequence is contractive, therefore Cauchy and hence convergent. So let x is equal to limit of xn. Therefore, limit of xn plus 1 as n tends to infinity is also x. Am I right?
Yes, sir.
Therefore, limit of xn plus 1 is 1 by limit as n tends to infinity 1 by 7 times xn cube plus 2. This is xn, right? Xn plus 1. So, by properties of limit, it is just 1 by 7 times limit of xn cube plus 2. But xn cube means it is a product of three sequences xn, 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 and we know that limit of product is product of limits. So 1 by 7 times limit of xn its cube plus 2, right? Because xn cube means xn, 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 so product of 3. So 1 by 7 times x cube plus 2. X is the limit of xn. So what is left hand side? Limit of xn plus 1 is x. And therefore x cube minus 7x plus 2 is equal to 0. So therefore x satisfies the cubic equation. X satisfies the cubic equation x cube minus 7x plus 2. Actually, what is the limit of the sequence? Number x, but that x is a solution of this cubic equation. And there are some techniques to find. So right now it is not convenient to find exact value of x, but there are certain techniques with which you can find limit of this sequence. And probably there are, so this is a cubic equation means it is a function basically. And or you try to find, is there any technique to find root of such equations, right? So, or if possible, I will send you the some content with which you can find roots of such equations. So there are methods to find roots of polynomials. So Ferrari's method or Cardan's method. Right, so, but this thing is not part of our syllabus, so we'll not waste time on this. Our aim is not to learn this at this course, but anyway, certain methods are there and how to find exact root. More on in next semester calculus, using the properties of continuous function. Also, we can find the approximate root of such equations. Right, using calculus also it is possible. So, and continuity of functions, we can find roots of such equation. But one important information we obtain is key, if limit of this sequence is x, then x satisfies this cubic equation. Right, so this is a way people do research. Key, if you want to find something, then they get some equations. And they know that key, our solution is in this equation. If you solve certain equations, our solution uh, is inside this equation. So they try to solve such equation and they invent methods to solve such equations. And then they get the solution exact they want. So this is a way, right? And to solve such equation, that is a different thing. But point is key, we can find a root. Okay, is it clear what I am saying?
Yes, sir.
Sir,
Right.
I had a doubt.
Yes.
Sir, if we consider the sequence xn is equal to 1 plus 1, 1 plus 1 by 2 plus 1 by 3 up to 1 by n, the it as by the result we get, it is a convergent sequence. But
No,
as
no,
we
no,
see,
no, 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 no. No, no, this is not convergent. We have not proved at all it is convergent. What we have proved? Xn is monotonic increasing. This is true. But
but
it
sir,
is
if
not.
we check the distance
No,
between
no.
xn plus 2 and xn plus 1 and xn plus 1 and xn, we get it is as equal to n plus 1 upon n plus 2 into xn
No,
plus
no,
1
no.
minus xn.
What is x1? What is x1 minus x2? What is distance between two terms? 1 minus What is x2?
1 by
Right.
2.
So this is 1
3
by
by
2.
2.
Now what is distance between x2 and x3? What is distance between x2 and x3? What is it?
1 by 3.
It is 1 plus 1 by 2 plus 1 by 3 minus 1 minus 1 by 2. Right. And it is 1 by 3. But is this distance between two terms, distance between next two terms is a constant times? There should be a constant. There should be a constant.
So,
Can
we
you
get a constant n plus 1 upon n by n plus 2.
n plus
N plus 1 upon n plus 2.
n n plus 1 upon, is it a
N plus
constant?
2.
Is it a constant? Is it a constant?
No, sir, it's varying with the terms now.
So constant should not vary with n. You understand? Definition. Contractive sequence. What is the definition? Constant should not vary with n. What constant in this example we found? 3 by 7. It is not varying with n. Do you understand?
Yes, sir. Yes, I got it.
Right. So that is the difference. So here it is not possible to find a constant so that the distance between next two terms is less than constant times previous two terms, which is not going to happen in this case. By the same amount, same fraction, the terms should be, see what is a, so if you think on this, just spend 10 minutes and think over it. When I say xn plus 2 minus xn plus 1 is less than or equal to c times xn plus 1 minus xn, that means whatever in this example you said the distance between xn plus 2 minus and xn plus 1 is less than, so distance between previous two terms, these two terms is less than previous two terms. That is true, but is it reducing by a constant factor? Right, it should be reducing by a constant factor. That plays important role. Right, only less than is not sufficient. Right, so xn plus 2 minus xn plus 1 is less than xn plus 1 minus xn does not imply Cauchy. Right, this does not imply, only less than is not sufficient. It should reduce by some fixed constant factor, and that constant factor controls the terms. That is a controlling factor basically. Right? So you should think about such kind of things. What is the role of C? You see the proof of contract to implies Cauchy.